So today we are going to talk about polynomials. Polynomials. Now, a polynomial came from the word poly, meaning many, and nomial, meaning terms or numbers. Now, a polynomial can have variables or any constants like 1, 2, 3, 4, 5. And last but not the least, it could have exponents like x raised to the first power, this is an exponent, or y raised to the third power, this is an exponent. Now, a polynomial can be used in addition, subtraction, multiplication, and division. And one thing is that if we could label what a polynomial is, we could also label the polynomials that are not polynomials. So what I mean is we could classify what is a polynomial and what is not a polynomial. So one thing about polynomials is they could not have a negative exponent. So for example, 7 raised to negative 2. This is an exponent and it has a negative sign. So it is not a polynomial. Or if it has a variable in its denominator, like 2 over x or 3 over x plus 2, they still have variables in their denominators. So these are not polynomials. Not polynomials. Now that we know what a polynomial is and what are not polynomials, we could classify them as a polynomial like monomials, binomials, and trinomials. Just think of cycles like the bicycle or the tricycle and the monocycle, Because a monomial has only one term, a binomial has two terms, and trinomial has three terms, and so on and so forth. Three terms. Now, a polynomial can have an infinite number of terms like x squared plus x plus 7 and so on and so forth. Or it could not have variables at all. This is a polynomial. 7 is a polynomial. It could have no variables and it will still be a polynomial. So now we move on to the degrees of a polynomial. You would need this one because it would be needed in the addition and subtraction, multiplication and division of polynomials. Now, the degree of a polynomial, a one variable polynomial, degree of a one variable polynomial. So to identify the degree of a one variable polynomial, you should always just look at the variable. So for example, if I gave you 4x raised to 3 or 4x cubed minus x plus 3, we would only look at the variable, which is x. And because if we have one variable, which is x, and not xy, we only have x, the letter x, then it states that the largest exponent of that variable x, is the degree of the polynomial. So let me explain it to you. So 4x cubed minus x plus 3. The degree of the variable x 4x cubed, x cubed has a degree of 3 or exponent of 3, and x here has a degree of 1 because x raised to 1 is equal to x, or even y raised to 1 is equal to y. Now we could say that it says that the degree of in finding the degree of one variable, the degree is the largest variable with the largest exponent. So this term is the one with the largest degree or the highest degree. And the highest degree here is 3. So it's a third degree polynomial. Now what about this one? What if it is maybe 4x? It's 4x. I'll let you answer that. 4x z squared minus z plus 3. The third one is x squared plus 2x raised to the 5th power minus x. So here's how you label the degree. You always look at the variable. So in 4x, the variable is x. And x is just x raised to 1, which is a first degree polynomial. So it's first degree. So z squared minus z plus 3. The largest exponent of the variable z is 2 and not 1. So the largest variable or the degree of the polynomial is the second degree. Just remember that if it's a constant, it has 0 as the degree. Just remember, when you're finding the degree of a polynomial, you should always look at the highest exponent. Now, x squared plus 2x raised to 5 minus x. Now, x squared has a degree of 2, x has a degree of 1, and 2x raised to 5 has a degree of 5. Which has the greatest variable, or which has the highest degree? It is 2x raised to 5, which is the 5th degree. Now, in finding the degrees of a polynomial, it's not always one variable. It could also be in two variables. For example, maybe xy4, or maybe 8xz. And to find the degree of both, you just have to add the number of the exponents per variable. For example, I'll teach you how. For example, x y raised to 4. X, as I've told you, if it doesn't have a number on the top, it's always 1. So x has a variable of 1. And y raised to 4 has a variable of 4. So that's 1 plus 4 equals 5. This is a 5th degree equation. Or it's a 5th degree polynomial. 8xz, x has a variable of 1 and z has a variable of 1, so it's a 2nd degree equation. That's how you do it if it is in two variables. This is in two variables, or it could be more than one variable. It could be 3 variables or maybe 4 variables. One thing and the last thing to teach you is the standard form. So you might ask me, what is the standard form? So the standard form teaches you how to arrange polynomials, by their degrees or alphabetically arranged order. Now, this is how you do the standard form. What did I write? Standard polynomials. It's standard form. So the standard form is just doing it in from the highest degree to the lowest degree and in alphabetical order. So let's try this one. Let's try putting this polynomial in standard form. So I'll give you an equation and I'll just give you maybe, you could pause the video if you would like to. So xy raised to 4 minus 5x squared. Let's just fix that. You could pause the video if you'd like to answer it by your own. Minus 5x squared z. Now put this in standard form.